Hello everybody, today I'm going to explain the solutions for the AtCoder Beginner Contest 162, the contest I have just won. Let's begin with A. For the problem A, we are asked a simple requirement, namely checking if a 3-digit integer has the digit 7. This can be done in constant time with a if statement. Basically, we are going to check if either the first, second, or the third digit are equal to 7 and pick yes or no accordingly. For the problem B, we are given the fizz-buzz sequence, a sequence which is defined in the problem statement, and we are asked to find the sum of the numbers among the first n terms of the fizz-buzz sequence. Since n isn't big, we can literally run a naive approach, check if each number from 1 to n is a fizz-buzz number, and otherwise add it to the sum. Basically, I have checked in a for loop this property, and if this property doesn't happen, I just add up to the sum the number I. And we need to be careful because the sum can sometimes overflow, and we need the long data type. For the problem C, we are asked again a very simple question, namely finding the sum of GCD of all tuples of integers in range 1 to k. Since k is small, we can actually brute force all the pairs and find the GCD for each of them. This is again another implementation exercise which can be done with a for loop. Here we can observe that we have a for loop which we have picked all the possible pairs, and in order to speed up my implementation I have used the inbuilt GCD function, which is good in this case because we don't have numbers equal to 0, and it allows us to do GCD in logarithmic time. Overall, the complexity would be k at the third multiplied by logarithm of k. Let's move to the problem D. The problem D is the first non-trivial task, which asks us to find the number of good triples which satisfy the conditions given in the problem statement. And this can be done quite easily if we observe a really important observation. Let's assume we found the triples which satisfy the first condition, like none of the letters in the triple are equal. The number of the triples which don't satisfy the second condition is actually small because the number of triples which have difference equal is actually bounded by n squared, not n at the third. Because uh, if we fix the difference of the first two numbers, the third number can be found in constant time. Now let's move on to the implementation. In this case, I have used a suffix sum array, which is basically the same as the prefix sum array, but we compute the sum from the back to the front, and we have created such an array for each letter possible. This will help us reduce the complexity from the n at the third to n squared, therefore getting accepted. Now I have fixed the first two numbers from the pair and checked if the letters are not equal. Then in this if statement, I have checked if the third number, which would fulfill the first condition but not the second condition, is actually a valid number for the first condition, such that we can drop from the answer. And then again, if this doesn't happen, we don't drop anything. But if it happens, we need to drop one from the answer because that position would be found here. These ifs help us to check which letter is missing, and according to the letter which is missed, we are going to add to the answer the number of such letters, as you can see here in the count presented. Again, the answer can pass the int limit, so we need a long answer. Let's move on to the problem E. Problem E is the hard version of the problem C. As you can see, it is actually stated in the title that it's the generalized version of C, and we're asked to find the sum of all the GCD for all the arrays of length n which have integers between 1 and k. Since n and k are big, we can't use the method for deceive, so we need to think of something more clever. Fortunately, this problem can be solved using inclusion-exclusion, which can be implemented quite easily if you know how to do it. Basically, let's fix the number of the GCD sequences which return us a GCD equal to some multiple of k. If we have uh, a number I, the number of possible numbers we can add in some position is k divided by I. Can be seen by simple math, and the number of sequences which have GCD equal to E would be that number raised at the end. Unfortunately, this is not correct because let's say we have length equal to 3 and the maximum number is 6. This formula would also return us a sequence like 66, which is not good. So we need to actually drop from this number the number of sequences which have GCD equal to each of the multiples of I. This can be done in n log n time by harmonic series, which is basically an implementation similar to the sieve of Eratosthenes, and it helps us find the answer. Last but not least, since we are required to find sum of GCDs, we need to multiply each count with the number I in order to get the answer. We should also be careful at dealing with the mod parameter in order to avoid overflowing. Let's move on to the problem F. The problem F is quite an interesting task. We are asked to find n squared elements such that now two elements which are neighbors are chosen, and we need to find the maximum possible sum. During the contest, I have observed that this problem has a generalized version in Japanese Olympiad, and I proceed to take my submission from there in order to get accepted, which allowed me to get F 2 minutes instead of thinking at it. But assuming you wouldn't know about the existence of that problem, which actually is quite a hard problem and is not uh, okay for people who are beginners to check it, the main observation would be basically to either too greedy or DP. The greedy approach is basically observing the fact that if n is even, we can take either even position or odd position numbers, eventually moving some number from one of those sequences. And it is a casework which can be done in linear time. If n is odd, the casework is similar, except we can actually move up to two elements, and we need to choose what to move. This can also be done by DP, with a simple recurrence, which again is linear. But this is the story for another video. If you liked watching this video, please like the video, check my channel for the other videos, as well as subscribing for more competitive programming content. And also join the Discord server in order to be notified whenever I publish some video. Until the next time, stay safe, stay healthy, good luck, and goodbye.